literally doing everything we did last chapter in one section, kind of. Analyze the graphs. And I'm particularly going to be looking at just 4 types of graph. We'll start with our 2 basic ones that we know and love by heart. Good old Mr. Parabola, or the f of x equals x squared function. And then good old Mr. Upside Down Parabola, or f of x equals what? Negative x squared. Okay. When they say on tonight's homework, analyze the graph, then they're going to say the following. State the domain, the range, the intercepts, the end behavior, the increasing, the decreasing, and the continuity. I just want you to state the following on your homework tonight. Move this up, okay? I want the domain, the range, the end behavior, the continuity, where it's increasing and where it's decreasing. I don't need the x and y intercept. I'm going to safely assume you can find those. So on tonight's directions for homework tonight, when it actually says that, just do these 5 things, or 6 things, sorry for me, okay? So let's analyze this. This is everything we learned last chapter. What is the domain? How wide is this picture from where to where? Negative infinity to infinity. Okay. How tall is this picture? From where to where? 0 to infinity. You can bracket a 0. It is closed there. For end behavior, I want something different. In the last chapter, we would say as x approaches negative infinity, y approaches, we do all that, right? I don't want that. There's a method to my madness. Just know that I'm mad for a little short time here. I want you to just look at the ends. They're both pointing up, correct? So you go like this, up, up. There's reasons. Continuity. You are continuous along your domain. Let me say that again. You are continuous along your domain. My domain was negative infinity to infinity. So where am I continuous? From where to where?
So it's the same thing.
It's the same thing. You are continuous along your domain. There's no discontinuities in this picture. All right? Increasing and decreasing. Let's look at my pencil now. My pencil, if I start on the left, is going in the down direction, correct? It's decreasing. From where to where? Now this one you do on the x. So from where? Negative infinity to 0, it's decreasing. And then my pencil increases, correct? 0 to infinity. That's all you're doing for homework tonight. It's called analyzing the graph. It's literally doing everything you just did last chapter in one. Now, let's take this same thing and let's do it to the negative x squared. So let's see what changes. Domain, range, end behavior, continuity. Where is it increasing? Where is it decreasing? So let's see, what would change from here? Does the domain change? How wide is this picture getting? Does it change?
No.
No. So negative infinity to infinity. Does the range change?
Yes.
Or is it from where to where?
Negative infinity.
To 0, you can bracket that one. Does my end behavior change?
Yes.
Yes, you would write 2 arrows that are going down. So it starts down, it ends down. Continuity, you are continuous along your domain, so you are literally going to rewrite whatever your domain is. What about increasing and decreasing? Is that going to change?
Yes.
Yeah, so you are now going to be increasing from left to right, so you're going to be increasing from negative infinity to 0. And then you're going to be decreasing from 0 to positive infinity. Okay, now, why is this so important? Well, here's why. on homework tonight, you're going to get a question that says this. Analyze negative 6x to the 6. Sorry about that. Kind of got in the way. Analyze negative 6x to the 6. So you don't have to do this in your calculator right now, but I'm just going to do it for you. Okay? I'm going to put in negative 6x to the 6. And I want you to see what happens here. Let's turn that off. Clear. Negative 6x to the 6th. Let's hit zoom 6. What's that look like?
Parabola.
A parabola doing what though?
Slightly over it.
So negative 6x to the 6th looks like this. Do you know that negative 6x to the 8th looks like this? Do you know that negative 6x to the 10th looks like this? What am I saying to you then?
The domain and stuff is all the same.
For what?
All even number.
All even power functions follow these two patterns. If it was a positive 5x to the 6th, it would look like this. If it was a negative, it would look like this. That's the only difference. All even power functions look like these. The middles, don't even worry about. All the domain and everything stay the same.
0.
How about 0? Well, 0 would be 1. That'd be constant. So maybe I should clarify. All evens greater than 0. Does it make you feel better? All right. So then what does that mean for the odds? What do you think? So again, for homework tonight, when it says analyze, I want domain, range, and behavior. Continuity, where is it increasing and where is it decreasing? And they'll list this out for you, but. And actually, I think we're going to do this one at the same time because you'll see it's not really that different. All right, so help me out here. What's the domain? How wide is this picture getting? If I were to just continue it, how wide is it going to go? Negative infinity to infinity. How tall is this picture getting?
Infinity.
Negative infinity to infinity also. So these two are the same. Is that true for this picture over here?
Yes.
Yep. All right, for end behavior, all I need you to do is write arrows. So always start left to right. So left is down, right is up. So you would just go down, up. There's a reason for it. When we get to it, I'll tell you why. End behavior on this one, though, from left to right would be up, down. Continuity, you are continuous along your domain. So whatever your domain happens to be, it happens to be negative infinity to infinity. And that would be your continuity. There's no problem areas. There's no holes. There's no jump. There's no asymptotes there. So we're okay. We're continuous. All right. My pencil, what is it doing the entire time? It is increasing the entire time, right? Do I ever decrease here? So I am increasing the entire time from negative infinity to infinity. I am never decreasing. So you'd write NA, meaning not applicable. What's my pen doing this entire time? Decreasing. So I would say from negative infinity to infinity, I'm decreasing, but I'm never going to increase. So again, what does this mean for you? Well, let me give you 3 similar problems, and then this is how easy homework is going to be tonight. It'll say, analyze the graphs. Power. Some of these are going to be a little different, and I'm going to show you which ones they're going to be. But we'll go through each one real quick. So what's number 1 going to match up with? 5x to the 7th. Which one is it going to look like? It's going to look just like this one. So you are just going to, this one right here, x cubed. It's Similar to x cubed. It doesn't matter what the middles look like. All the domain, the range, and behavior, the continuity, the increasing, the degree. Don't worry about that. It's all going to be pretty much the same. So it's similar to the x cubed. What about this one? 2x to the 6th. What's that one similar to?
The squared.
X squared, okay? The only time it would change would be if it would have a negative. Then you would go to the negative one, okay? But what do you think's different about this one right here? It has that negative. So I want you to look this one in the calculator then. You've got to look at the calculator, okay? So get your calculator out. Let's look at this. I'll punch it in mine. 2x to the negative 2. This is a very famous one you should kind of be aware of. It's like Mr. Volcano, okay? So it does have a few things that are different that you would actually take note of when you list out your 5 things. For example, number 1, the domain is different. The domain is what? From where to where? Well, first of all, do you agree I have an asymptote here? Okay, when you have asymptotes, you need to state that in your domain. So from negative infinity up until where? Where's my asymptote at? 0. So my domain is negative infinity to 0, united with, then what? 0 to infinity. That is your domain. What's your range? How tall is this picture getting? 0 to, sorry, I'm right there on the middle. 0 to infinity. You can actually bracket that 0, okay? End behavior, so end behavior is going to be different. This is that end behavior where it's not, as x gets more and more large, what is y approaching? 0. Even as x gets more and more negatively large, it's approaching 0. So you can actually just write y goes to 0 for both. That's fine with me. Your continuity, it'd be the same as your domain. Increasing and decreasing, well, again, look at your picture. What's my pen doing right now? Increasing on from negative infinity to where? To 0, correct? So it's increasing from negative infinity to 0. And then what does my pen do there? Decreases on that half. So again, they wanted me to actually give you this one. And I thought, you know what? You all can look in your calculator and do it. But that's what you do on homework tonight. Just look in your calculator and do that one. All right, I want everybody to do this one by themselves. X to the 5 halves. Put it in your calculator right now. List out these 5 things right now for me. Domain range, M6, I keep saying 5. Domain range, and behavior continuity, increase. This, remember, fractions are square roots or cube roots or anything like that. Remember, anything with the 1/2 power is a square root. This is actually, if you were to write this out, this would be the square root of x to the 5th. So you are allowed to take square roots of 0, but not negatives. And that's why you only have half a graph. You can't have negatives. So what's your domain right here? From where to where? How wide is this picture? 0 to infinity. Range, would you all agree it's the same? Mm-hmm. End behavior, so you only have half the graph, so you're only saying as x approaches infinity, y is going to infinity. You can write that. Or actually, you can. Some people were like in the other class, can I just write up on 1/2? I'm like, sure, it could just shoots up. Continuity, you would literally repeat what you have in domain. My pencil is increasing the entire time, agreed? And it's increasing from 0 to infinity. Is it decreasing? Not applicable. So they, like I said, they wanted me to break all these down for you, but I think you can easily look in your calculator for that one. Not hard. All right, 9, number 4. It's our last thing for today. I know you're kind of done in. We're almost there. Almost there. First things I need you to do before you even, because if you don't have this on your calculator, you're going to get it wrong tonight. I need you to go to mode and then go down. I know it's hard to see. Go down to where it says stat diagnostics and make sure it's turned on. Is your stat diagnostics turned on? If it's not, turn it on. I'll write that down for you. Mode, stat diagnostic on.
Where's that at?
Mode, and then go down where it says Stat Diagnostics. Right now mine is on. You would arrow over and hit enter. Okay, that will be important for what you're doing for homework tonight. So what we're gonna do is your book, and mine, I would let you guys see it on mine, but my projector makes it so blurry. That's why I'm making you open your book, guys. Sorry about that. But on page 89, we're going to do number 4. We are going to make a scatter plot of the following data, which is representing resting metabolic rest heart rate, I guess, in kilocalories per day for the mass M in kilograms of several selected animals. So what I want you to do, in your calculator, you're going to put in L1 all the M's. And then in L2, you're going to put all the R's. If you don't remember how to do that, I'll tell you how to do it right now. You hit Stat, Edit, input your L1 and your L2. So hit Stat, Edit, and I already did it in the last class. That's why I'm not going to do it right now. It's a lot, but I need you to do it right now. I need you to put it in your calculator and you would get very interesting stuff. But so power regression, we're going to create the scatter plot now. So the way you do that, when you hit stat, anytime you hit stat, in order to graph it, you have to turn on the stat plot. Do you see how it says stat plot right here? So you hit, I'll write this out for you, second y equals, and right now mine says plot 1 off. Does yours say off? So you're going to go into it, you're going to hit enter, and you're going to turn it on. And you're going to pick the first type, which is your scatter plot. You could obviously do box and whisker plots, you can do bar graphs, but we're going to do the scatter plot. So that's our first type. It should say L1 and L2. So second y equals, and we're going to turn it on. And then once you do that, you can't just hit, oh, graph. You have to tell the calculator to graph your stat stuff. And the way that you do that is you hit zoom 9, which says zoom stat, zoom 9. So I'll write that down, zoom 9. Now, yours should look similar to mine, except for what's this right here? Anybody know what that is?
The line of best fit.
No, it's not a line of best fit, that's for sure. That was my previous example. Remember when I put into the y equals, I actually put x to the 5 halves? That's all. I just have to clear that and then go back to the graph. Now it'll graph it without it. Okay, so if you ever see some random lines, that's what, you just have something in your y equals. Now, this is here, this looks like a power regression model because doesn't this look like the square root curve a little bit? I'm going to let the calculator find that regression model for me. And the way that you do that, write this down, is stat, calc, power regression, PWR-REG. Last year you did linreg. You were doing linear regressions. You're doing a line of best fit. We are now doing models that can be for square roots and squared and stuff like that. So stat, calc, go down to where it says power reg. And then just hit enter, enter, enter. And then it gives you this formula right here. My formula says, and yours should say this too, y equals ax to the power of b. Okay. They told me, according to mine, and yours, mine might be off because I was kind of, my eyes were getting blurry as I'm looking here. 69.6. So the what you're going to write would be y equals 69.6 for A. Is that what yours is? Is yours 69.6? Okay. X to the what B power would be, I have 0.76. This is my regression model for that question on animals' resting metabolic rate and their kilograms. So I can actually predict what their metabolic rate would be based upon their kilograms. I could do that for an animal based upon this prediction right here. Now, there's one more thing you need to look at. Do you see this R value right here? That was the first thing you did. That was from your stat diagnostic. My R value is 0.995. Do you see that? Write this down. Actually, I think it's 0.996. Yeah. Okay. This right here is called the correlation coefficient. And what that means Hello? Okay, thank you. Bye, David. You have to go. What this means is the closer this number is to 1 or even -1, the closer that number is to 1 or -1, the more accurate the regression model is. In statistics, I don't want this to be like 0.75. That's not really a good model. I want this to be 0.99 or 0.9 something. The closer it is to 1 or -1, that means I chose a good regression model. So they're going to ask you on homework tonight, what was the R value? What was the correlation coefficient? Okay. And that's it. That's all you'd have to do. You might have to just kind of sketch the graph. You know, mine looked like it was here and then there was one over here. And that's all you'd have to do. There will be ways, I will show you how to actually input that regression model into the calculator. But if I remember correctly, actually,